Hey, thanks for joining us here on the Big Bear Math channel. Today, as we work through Chapter 2, Functions and Graphs, we're jumping into Lesson 3, where we focus on equations and functions. And this may be a real pivotal point in your math career. This may be the first time where we've started to replace the y variable with the notation f of x. And I think it's kind of exciting to start to do that. Okay, so there are several advantages to solving an equation for y. And many of which we may not even discover, tonight or even this year. But as you go through your math career, the advantages seem to never end. Now, when we do solve an equation for y, it's common to rewrite it using something called function notation. So let's consider this first equation here. So the equation, it says 2y minus 4x equals 10. And our goal is to try to solve for y. So we could talk about, maybe adding a 4x to both sides. And these bears would cancel, so I get 2y equals 4x plus 10 because I couldn't combine them. And then I'm going to divide everybody by 2. Every term gets treated the same. So we get y equals 2x plus 5. And worth noting, this equation is equivalent to the original one. It's just written in a different form. And now we would say that y is a function of x. Anytime that y is by itself, okay, anytime y is by itself, we'd say y is a function of x. And to me, the easiest way to process that is to say the value of y depends on the number you substitute for x, okay? And so therefore, y is a function of x. Now, because of that saying, y is a function of x, we get into this idea right here, that when we say y is a function of x, it's written by functional notation as y equals f of x. In other words, y is the same thing as f of x. Those two ideas are interchangeable. So what we could do is we could take y equals 2x plus 5 and just rewrite it as f of x equals 2x plus 5. Now, if this is the first time you've ever seen f of x, yeah, it's going to be uncomfortable for sure. But I'm going to ask that you kind of trust me, hang with me. And the more we do it, the more natural it's going to get. And unfortunately, it's not going to go away as we progress through the higher levels of math. Now, if there's ever a moment where you do get a little uncomfortable and you say, man, I really don't know, I don't like that f of x, you can always take this f of x and rewrite it as the y. Okay, so real quick here, a couple of definitions. That x value is called the independent variable. Okay, that's your independent variable. A lot of times I like to refer to that value as the input value. Y is then your dependent variable because its value depends on whatever you plug in for x. And I like to call that my output value. I like the terms input and output. I like to keep things simple. Now, if you recall from our last video, we talked about linear equations. When they're defined in two variables, they have an infinite number of solutions, okay? And if you were able to list all those solutions out somehow, all of the x values would make up what's called the domain, and all of the y values would make up what's called the range. Okay. Real quick, we're trying not to go too fast, but I do want to get through these definitions so we can jump into those real meaty live examples. Now, some definitions that you're going to see from time to time. A relation is any set of ordered pairs. Okay, it's like a whole cluster or group of ordered pairs. And they said each value of y is paired with one or more. Emphasis there. If you're writing this down in your notebook, I would emphasize that, highlight, one or more values of y. So you might have, you might have 2, 3, you might have 2, 4, you might have 3, 1. I'm just making these up as I go. And you might have 2, -6. Notice how there's an x value of 2 that got paired with 3 different y values. And that's okay if it's a relation. But then we graduate to a more strict definition here of a function. And a function is a specific type of relation in which each x is paired with exactly one y. So instead of one or more, we came back and we said exactly 1. So the previous example I gave you would not be considered a function because this 2 was paired with a 3, a 4, and a -6, and that's a big no-no. So it's a relation, but it wouldn't be a function in that case. And one of the things we like to use is something called the vertical line test. And we'd say, okay, if the if the relation truly is a function and you graph it, the vertical line will never intersect a function more than once. Okay, that'll never happen. So let's say I have a graph. Boom, 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 boom. All right. Now I should be able to draw a vertical line anywhere I want. Okay, we've got the freedom to do this. Draw it anywhere you want, and you'll never have more than one intersection. Okay, so that black line was an example of a function. Now consider this graph right here. All right, consider this graph. We call this like a sideways parabola. Now notice when I draw a vertical line, say right here, see how I've got 1, 2 intersections? So that would be an example of a graph failing the vertical line test, and it's not a function. Now, without further ado, let's get into some examples tonight. So initially we had this equation y equals 3x minus 1, and then we rewrote it in function notation. So now it's f of x equals 3x minus 1. And we want to practice evaluating these. So what you'll notice is when they say f of 1, okay, and you almost have to practice saying that out loud, f of 1. What they're saying is we want to substitute that 1 for x, okay? So it's very important to note that that number in the parentheses is your x value. So think about substituting or replacing that x with a 1. So 3 times 1 minus 1 is going to make 2. So in other words, 1 comma 2 is a solution to that function. And when we go to graph it, the graph's going to pass through that point. Okay, again, f of negative 4, that's an x value. So 3 multiplied by negative 4 minus 1 is going to make negative 13. So negative 4 and negative 13 is another solution, and the graph will pass through that point. All right, what if x was 0? 3 multiplied by 0 minus 1 makes negative 1. In other words, 0 comma negative 1 is a solution. Ooh, here's a fun one. 3 multiplied by 1/3. So 3 multiplied by 1/3 makes 1, and then 1 minus 1 makes 0. So 1/3 comma 0 is going to be another solution. So there's 4 out of, a million bazillion solutions. Every point on that graph is considered a solution. Okay, the next exercise I want to practice is I just want to get in the practice of converting these equations. Right now they're in standard form. And we want to try to solve for y and rewrite them in function form. So the first thing I'm going to do is I solve for y is I'm going to go ahead and I'm going to subtract this x from both sides to give me negative 3y. Don't forget your negative there. Equals negative x plus 12. And then I'm going to divide everybody by negative 3. Show all my work best I can here. So you're left with y equals positive 1/3 x minus 4. So there was like an invisible 1 there, and 2 negatives make a positive. So that's why that 1/3 is positive. And again, our function notation says we're just going to replace the y with an f of x. Nothing fancy. It's just kind of learning a little bit of a new trick up our sleeve tonight. Okay, next example here, I want to add 3x to both sides. So we're left with 1/2 y equals 3x plus 5. And here's my personal preference here is, we're trying to get rid of that 1/2. Some people may prefer to go ahead, you know how we divided everybody by negative 3 on this side? You could do the same thing. You could go through and divide everybody by 1/2 in this example. I'm going to use a slightly different trick, although it achieves the same thing. I'm going to multiply every term by 2. So when I multiply the 2 and the 1/2, that makes 1y. 2 times 3 makes 6x, and then 2 times 5 makes 10. And again, now we were able to solve for y. We'll rewrite it in function notation, functional form, and that's our final answer there. Okay, we're going to wrap up with this one last example. And so we've been given a function f of x equals 2x minus 14, and they want me to solve f of x equals 0. So what exactly does f of x equals 0 mean? Not to be confused with evaluating f of 0. See, in this case, if I put the number inside the parentheses, that's like your x value. But in this case, if I set f of x equal to 0, I'm basically saying y is equal to 0. So what I'm going to do is I'm going to basically replace this f of x right here with a 0. And then all we got to do is solve for x. So I'm going to add the 14 over divide by 2, and the solution in this case would be a 7. So what are we really saying here? We're saying when y equals 0, the corresponding x is 7. In other words, 7 comma 0 is a solution, and that's a point the graph would pass through. And if you wanted to check that, you could evaluate f of 7, which would be 2 times 7 minus 14. And 14 minus 14 makes what? 0. So that's our way of checking that answer. So, ladies and gentlemen, I know the first time you start to replace y with f of x, it's an uncomfortable feeling. It feels like an unnecessary move, and we're making it more complicated than it needs to be. But trust me, hang in there. It's going to pay off down the road, and I hope we're going to get 1% more comfortable with that idea each step of the way.